Okay, so let's start. Can you confirm if you can hear me, if you can see me? Anyone?
Yes, sir, can hear you.
Is my video working?
Yes.
Yeah, okay. So let's start with the first problem. Is the font okay?
Yes, sir.
And can you see my cursor?
Yeah.
Yeah. So please go ahead. Let's take 15 minutes maybe for this problem, and then we'll go over it together. I pasted two test cases in the chat, so in case you want to verify, they are in the chat. Yeah, I'm muted. How many of you are done? Nobody's done?
So why are there two lists given?
Hmm?
Why are there two lists given?
Why are two lists getting?
So like rain average, Bombay, and then 848, and then again one list. This is one list in the first line, and again we have a second list in the second line. Why are there two lists given? So this is first line, the one list,
Yeah,
and then again
first
the
line, okay.
second list. That's the first list, and this is the second list.
Uh,
So why two
yeah,
lists are there?
this is the input to the function. So this is what you are expected to return. This is the output.
Okay,
This
this
has
is the
nothing to
output.
do with this. Yeah.
Right, right.
Yeah, this is
Okay.
the output, just so that you can cross check.
Okay, thank you.
Anybody done? Maybe raise your hand.
Yes, sir. Done.
Those who are done, can you please raise your hands? I just want to get an idea. Okay, only one. Okay, so it's time. How many of you attempted the question? Please raise your hand. Just attempted the question, not solve, just attempted. Okay. Okay, so let's start. Okay, so is the font visible? I mean, is it okay? Is it too small, too big?
It's okay, sir.
Yeah, okay. So question is, we are given data of different cities. For every city, we have the annual rainfall. We may have duplicates in our data. Basically, this may be from 2010, 2015, and so on from different years. Our job is to get every city, sum up the values of different years and take the average. So basically, we have three jobs. Uh, Identify the city, uh, sum up the rain values, and take the average. For taking the average, notice that we need to know how many entries we have per city. So there are three things we want. We want city, we want rain values, and we want how many rain values there are for the average. So uh, let's start. Let us create a dictionary to store these values. In our dictionary, we'll store values as follows. We'll have a city and it will store a list. The first one will be values and the second one will store how many times have I added a value. Okay, so let's say we see Bombay and 848. we'll create Bombay 848, comma 1. So this will be our first entry. So next time when Bombay hits, we'll add 948 to 923 to it, and this will change to 2. So in this way, we'll update the sum here, but because we have to compute the average, we will keep note of the count as well. So what do we do for, so this is a list of tuples. So let's say for item in data, the first value is the city. So city is item 0, and the rain is basically item 1. Okay. So now what we have to do is we have to add it to the dictionary. Now there may be two cases. Either we have never seen it or we have seen it. In case we have seen it, we will have to basically update the values. If we have never seen it, we are setting it for the first time. So uh, let's say if not in, or if in, yeah, let's say if in averages dot keys. This is a method for dictionary averages. So what it does is it returns the keys that averages has. Right now it is empty because there is nothing in that. So if city is in keys, what we want to do is averages that city, its zeroth value, that is the city. Yeah, so that is the, yeah, that is the value. We want to update that by rain, and we want to update the count by 1. Okay, simple. If we have seen this city before, update the values. Now, in case we have never seen this, we're seeing it for the first time, we do this. Averages city is equal to rain, comma 1. Okay, we're setting it for the first time. If we have seen it, we will update the value. So now we have a dictionary like this. Let us print this for the time being. Okay, so this will return none for the time. Python solution 1. So we get 177.2, 231.2, 201.1. Okay, is that correct? Bombay is twice, Madras is twice, and Bangalore is once. Yeah, 201. So now what we have to do is we simply divide this thing by how many times we have seen it to get the average. Yeah. Also, what we have to do is we need to sort uh, this based on the city name, that is the alphabetical order. So let us create a new list. Yeah, let's say output. And what we do is we key comma value. By the way, are you guys familiar with this syntax? Let's say you have a dictionary equal to, let's say one is A, 2 is B. So temp dot keys will give us 1, 2. Temp dot values will return A, B. If I supply items, it will give me both 1 A, 2 B. Okay. So when I write something like this, we will store it like this. We will have key comma value 0 divided by value 1, or key comma value in averages dot items. What I'm doing is this is equivalent to for key comma value in averages dot items, output dot append key comma value 0 divided by value 1. So this is same as this. What we have written above, this one liner, is same as this. Okay, so I'm using this because you've used list comprehensions in your lectures. So just to clarify that, whatever way is feasible to you. So now we have the average values. Now all that remains is to sort it. So let's print this first. Let's try out. So we have 885, 115, 201. Is that the correct answer? Yeah, 885, 115, and this. So now we have to sort these. Now in Python, you can sort a list using this. Let's say python.sort. You sort the list in place. That is, you don't have to write output is equal to sort. Now you need to tell it that I want to sort based on this key. Okay. So it takes a keyword, that an argument that is key. In key, you can supply what do I want to sort on. Now let me teach you something first. You haven't covered this in your lectures, but this will come in handy. By the way, any doubts up until this point? Otherwise, we'll clarify that and then proceed. Does anyone have any doubt up to this point in the list comprehension or anything? Fine. So there's something known as a lambda function. How many of you have heard of lambda functions? Explain the last line. Okay, so 5 of you have heard of lambda functions. Okay. So the last line, basically this line, it is equivalent to writing for key comma val in averages dot items. So it will iterate over every key value pair, and then we just do this. That is, we had output is equal to this, and we did uh, output dot append. We append another list, that is key value 0 divided by value 1, which is just the average. Okay, so this one line is same as these 3 lines. You iterate over this and you append this. Is that clear, Vinay? Yeah, I'll clarify lambda functions. So lambda functions are a handy tool in Python. So normally you define a function like this. Let's say func this, and you will return x plus 5. So func 10 will be 50, right? Now in Python, sometimes when you have a very simple function and you don't want to do this define thing, you can write it like this. Let's say func is equal to lambda. Lambda takes an input x and you return x plus 5. This is same as the one above. So if I do again func 10, it will return 50. So this thing is equivalent to this thing. Okay. This is usually used when a function is very simple and you don't want to spend def or something like that. This is also useful if you want to supply it as an argument to another function. Okay. So in your case, we want to tell it to sort based on the first value of our entries. Notice that all our entries look like this. We have this city value. So let's say I define a function, return city, and it takes data, let's say, and what it's supposed to do is return I0 or I in data. Let us say it's something like that. Yeah. So if we print output return city, yeah, so you see this function, basically this function returns city. It takes this list that we have, city value, city value, city value, and it only returns the cities. Okay, so if we have this function, we can tell the sort function, okay, sort my basically list based on this thing, return city. So let us try that. If we do this, let's try I0 for I India. Yeah. This object is not callable. Yeah. So you can supplement this by a lambda function. That is, let's say we had def func, we did this, return x plus 5. So in this case, what we can do is, instead of defining a function like this, because we want to supply the value here, we will say sort them based on the following function. That is, I'm defining a lambda function. It takes x. X is whatever input lambda takes. Return me the first element of x. So this is a function. I am telling you to sort based on this function. That is, I'm only supplying you the cities. Sort it based on cities. So if we try this, we get Bangalore first, Bombay second, Madras third. Okay. So again, what are we doing? This part should be simple. Okay. We're just counting the values. Then we take the average. Up to this point, everything is clear. Now, this is the main part. That is, how do you sort it? In order to sort it, if you don't supply this, basically, if we had a simple list, it will sort it in alphabetical manner. Okay. Now, because our list is a complex data type, in this case, we have a list of lists. We want to tell it that in every entry that you see, sort it based on the first entry. So we write a lambda function like this. This x is, I mean, you can write anything, maybe item or something. And x is the input that we get from out. Basically, output is made up of, let's say, four elements. Every time it takes an element, that element becomes x. From that element, give me the first one. Okay, so in this case, let's say it will take Bombay and 848. It will return only Bombay. Next time, again, the lambda function picks up Madras and 103. It only returns Madras. And then, because we have supplied it as a key, we are telling it, okay, sort my list based on this thing. Is anyone confused? Yeah, it will work with multiple variables as well. Does anyone have any confusion with lambda functions? Lambda functions, let's say you have multiple variables. Let's say you had def function x comma y, and you want to return the sum. Return x plus y. So you can write it like this. Func is equal to lambda. It takes x and y, and you return x plus y. Again, 10 comma 5, 15. So x and y are the inputs that you supply, and this is what you want to return. So in our case, x will be output, and for every element, it will return the first one.
Sir?
Okay, so yeah.
Yeah. So when in your document, like the problem description, the output is list of tuple, but when we run here, the output is list of list. So is it okay to have any?
No, it just requires us to change this part. I have written it like this. We can write it like this. We replace the square brackets with the circle brackets. Is that fine?
Okay, okay, sir.
Yeah. By the way,
Sir,
there's another catch here. Yeah.
yeah, actually, in output function, why we are doing that value of index 0 by value of 1?
Because we want to compute the
Yeah,
average.
in like how it's working. I'm getting we are
Okay, okay,
getting
let me
numerical
show you.
values. Okay.
Let me show you. Let me show you. By the
Okay.
way, did you watch the previous recording? I explained the debugging mode in that. Are you familiar with that?
No, sir. Actually.
Yeah, okay, no issues. So for the typing, maybe just go with the flow.
Okay.
I will show you how it's run line by line. Okay, so we are here
Yeah. Okay.
inside the function. Let me reduce the font for this one so that we can see. Is it still visible?
Yeah. Yes, sir.
Yeah, okay. So at the moment, if you see averages is empty in the right hand side, okay?
Yeah.
And data
Yes.
contains the dictionary that we supply.
Yeah.
So we iterate over that,
Okay.
and because we're seeing it for the first time,
Hmm.
we set this. Now notice that averages has one value, Bombay
Yeah. Yes.
848 1. Okay.
Come on. Okay. Okay.
Now, yeah. So next time we come to Madras, we have not seen it before. So again, we update it. Now notice that this has
We
changed.
are two entries. Okay.
Okay. Yeah, two entries. The
Okay.
third time Bombay will arrive again. Okay. So this
Okay. I
time
can
we will
understood.
update this one.
Okay, sir.
Yeah.
At that time,
So
value
up
of
to
0,
this point,
840.
it's okay. Yeah, yeah. So now we have this dictionary. We have 171 and 2. 171 is the sum of the range values.
Yeah.
2 is how many times did I see new values.
Sure. Okay, I can understand.
So
Thank you, sir.
yeah. So now for the average, we just divide that.
Okay, okay.
Okay.
Thanks, sir.
Okay. Does anyone have any confusion? Yeah, just one more thing that I wanted to clarify. There is uh, one behavior in Python that is, let's say I write I in range, let's say 5. So this returns 0, 1, 2, 3, 4. Okay. Now, if I do something like this, it still returns 0, 1, 2, 3, 4. It doesn't make this a tuple. Okay. Now, in case I do this, I supply two values instead of one. Now I receive a list of tuples. So this behavior is slightly tricky in Python, that if you sometimes if you specify only one element inside single braces, it is expected that you are doing it for readability, basically. If you see here, we are using circle brackets, here we are using circle brackets, but it doesn't create a tuple here, it does create a tuple here. So it's just something to keep in mind when you're working with single elements. If you want to do it still, you should do something like this. Tuple integer is not, yeah, you have to do it like this. Something like this. So in our case, it returned a tuple because there are two values. So if there was only a single value, it would be a plain list. Something to keep in mind. So I hope lambda functions are clear. I hope sorting is clear. So let's move on to the second question. Visible? Can anyone confirm?
Yes, sir. It is visible.
Okay, thank you. I've pasted the test cases in the chat. So if you want to use them. Yeah, Gaurav, do you have a question?
Yes, so I'm using a for loop to go through the items. It is going through the entire thing, but towards the end it shows a none. And when it comes as none, I don't know where it's coming from. It goes to the for loop and says none object is not iterable. So I'm not sure where none is coming from. I tried to do an else
So
statement, elif statement saying if it none then break, but it's not working.
yeah, so none can be in two cases, uh, either the iterable, that is the thing you want to iterate over, is empty, or you are iterating over something that is not iterable. One of two things from.
I'm using the first use case from there. And that's when the none is coming towards the end.
So the first use case is
It goes through the entire thing, but then right at the end, it shows a none.
yeah, so maybe we'll look over it, yeah. Okay, so how many of you were able to do this? This may be trickier than the first one. Nobody? Okay. So I think it should be pretty clear that we should use recursion here, right? Because if you iterate without recursing, you don't know how many nesting there may be, like a nest inside another one inside another one. So recursive solutions are usually pretty neat, but a little confusing. So we do flatten. It's a list, it returns something. Our use cases are okay. By the way, I am audible, right? You don't need recursion. It would be preferable to use recursion. I mean, to me, the moment I read the problem, recursion comes to my mind. Okay. So we obviously want a flattened list. So what we will do is we will iterate over the items. Okay. If the item is not a list, we will append it to this. Okay. Append to flattened list. Okay. Now, in case it is a list, we will call this function again, and we expect that it will give us a flattened list. Okay. Now, assume that we have done everything that we wanted to do, and just calling it again, flatten like this, on a sub list returns basically a flattened list. Now, what will we do with the flattened list? We want to combine it with this one. Okay. So we will do flattened underscore list. We can do this plus equal to, or we can also do dot extend. That is the same thing. Okay. So what are we doing? We are assuming that this thing returns a flattened list, and we want to basically append it, concatenate it with our own list. Okay. Now, if we want to write this for item in list, if not is instance item list, if it's not a list, just append it to the flattened list. Otherwise, we do yeah, we send the item basically because it is an iterable. We send it to flatten once again. Now notice that if we call this, there is never a return function. So this will be an infinite loop. So we want this to return a flattened list. Return flattened list. Now I will show you this part of code in debugging mode. It is always good to run a recursive function in debugging so that we understand it. Let's first check if it's running or not. So we have Python solution 2, 1, 2, 3, 4, 5, 6 items. So let's try in debugging mode. Okay. We have solution 2. So when we call it, we have the initial list that we supplied and flattened list is empty. Okay. Notice in the call stack, there is one function flatten. Okay. Nothing else. We iterate over the items. The first item is 1. Okay. 1 is not an iterable. 1 is not a list. So this thing will pass. We are saying if it's not a list, append it. So we append it and now flatten list contains 1. Next time we come around, we have 2 again, not an iterable, not a list. So we append, now we have 1 and 2. The third time we arrive, now we have a list. Okay. So we skip over this and we come to this. We want to extend our base list, that is this one, which contains 1 and 2 with a flattened version of the item that we are supplying. Okay. So what are we doing? We are once again calling flatten on item base. Our item is 3. So notice that when we call this, we get two flatten functions. In recursion, every time the function calls itself, it is a new function entirely. This function will have its own flattened list. Notice that initially it is 0. Look at this. The original flatten, its flattened list has 1, 2. The new function that we called, its flattened is empty. Everyone has its own flattened list. It is a local variable. Every function call will have its own flattened value. So what will it do? It will iterate over its own items. What are its items? Just 3. So it goes over 3. It adds it to its flattened list. And now what will it do? We were expecting it to return a flattened list. It is returning a flattened list. So it returned a flattened list and we just concatenated it with our own list. Okay. Notice here that the original one had 1, 2. This one has 3. It returns this list here and we concatenate it with this one using extend. Okay. And when we call this, we see we have 1, 2, and 3. Okay. Anyone has any confusion up to this point? Recursion is usually tricky.
Again. No, just the extend function. So why are we appending the flatten list while we're calling in the flatten item? I understood why the recursion is used, but how are we appending that to the original empty list that we take?
Yeah, let me maybe use this instead of extend. Maybe this will make sense. I mean, are you familiar with this plus equal to?
I got it now. So sorry,
Okay.
I
Basically,
forgot the
just get
extension. Yes,
yeah
we are
yeah
just
get the extended list
concatenating
and
we are flattening the item and concatenating it in the resultant list.
the one who called, the parent one. The parent function has its own flattened list. It takes the flattened list of the child function, that is the function which was called from inside the function, and we extend our list. Extending is basically just concatenating at the end. Is
So
everyone
actually
clear
I
about this?
used append here, so it returned me the original list. So we should not use
Yeah,
append. So it's either plus equal to this or it's extend. Got it.
yeah, yeah. Does anyone else have a confusion? So what is instance? It will, what is it will return true. Yeah, is instance basically just compares the data type. So let us say I write is instance 1 integer, 1 is an integer, so it is true. if I say, okay, is 1 a float? It is not a float. Let's say I used 1.1. It is a float. It will be true. If I say, is it an integer? It will say false. So it is just comparing the data type. So if we write type 1.1, it is float. So it compares float and integer. It is not the same. So it's false. What is the base case here? I mean, actually, it's not a base case in our, I mean, in this case, we are iterating over the entire for loop. We are guaranteed that the list will expire. So you use a base case when you don't have, basically, you don't know how deep you want to go, okay? So in this case, I know that my list is finite. It is not an infinite list. So there will be some point when I will terminate out of this list. And when I terminate out of this list, I will return, right? Because there are only two things that can happen. My element is either iterable, that is, it is either a list or it is not a list. So when I keep on nesting, when I go inside, I will hit a point when it will not be a list. And when it will not be a list, it will call this function that is an append function, and I will not recurse. When I will not recurse, I will call the return function. So I am guaranteed to terminate. So this is the sort of base condition in this case. That is, I reach an element that is not a list. Is it clear, Niroj? Yeah, so let's try the debugging mode once again before we proceed. We have flattened this. We step inside. It defines its own flattened list. We go in. It's not an instance append. It's not an instance append. Then it is an instance. So we call a new flatten. Notice that this is very handy. You have two flatten functions, the parent one and the child one. The child one will have its own flatten. It will keep on going and return. Now we have 1, 2, 3. We have reached this point. So next is this thing, a double nesting. So we go over this. It is not a list. So we go here. We enter this part. We define a new flattened list. We iterate again. So we have 4. 4 is an integer, so it can append it directly. So it will append. Now our flattened list contains 4. Next time it comes over, it is an iterable. It is a list. So we recurse. 5, 6 return. Then we get 4, 5, 6. 4, 5, 6 will be returned to 1, 2, 3. Notice in this case, we have 1, 2, 3. This guy has produced 4, 5, 6. Now it will concatenate the two. Return 1, 2, 3, 4, 5, 6. So we've done this as well. Try this one. If I say only this is this, yeah. So please once again tell what flatten item does. And just read the question. In flatten, in case you have nesting, it will remove the nesting and just append all the values at once. Yeah, by the way, before we go to problem 3, Gaurav, did you fix your code? Yeah, okay. Yeah, so what was the issue?
I call as instance in elif. So as instance in elif is giving a none. So it doesn't matter what I put what function I use after that, it always kept giving me a none. That's non-iterable in for loop.
So did it work without that?
I just so the if statement till that I had it figured. The rest of it I just took whatever yours was. I still didn't figure out how to part.
Okay, so let's take 15 more minutes. Do not use a for loop, do not use a while loop, okay? I want you to use filter. In case you have a doubt anywhere in your code, that is you're finished part of it, but you're stuck at a particular point, you don't know how to do it, you can ask that. Okay, let me help you with one thing first, maybe a hint. In Python, there is something known as all and any. Okay, so pause for a minute, let me show you something. In Python, there are two functions, all and any. So their input is a list or any iterable of booleans. So booleans are basically either true or false. Okay, so if I write 1 equals 1, this is true, 1 equals 2, this is false. There are only two values, a boolean value. So what all does is it takes an iterable and it checks whether everything in the iterable is true. So if everyone is true, all says yeah, all are true. If even one of them is false, it says it's false. Any, as the name suggests, will check is anyone true. So let's say I do any in this case, it says true. This is also true. If everyone is false, only then it will be false. Okay, so this may come in handy in your code, all and any. It takes the input as a binary mask, that is true or false, and all says if everyone is true, I will return true. Any says if even one of you is true, give me, I will return true. So this may come in handy. By the way, you've used filter, right? I saw your lecture PDFs, they had filter. Can anyone confirm? I'm pretty sure they had filter in them. Yeah, thanks. Yeah, by the way, I pasted these words in the text in the chat in case you want to reuse them. try to be minimal even if you want to use loops. In case you feel that it is unavoidable, yeah, you can use a loop. If you feel it is unavoidable. I mean, if you consider a list comprehension a loop as well, then yeah, you can do list comprehensions. Anyone done? Is anyone done writing but is getting the wrong output? I mean, you have finished writing, but you're getting the wrong output. Yeah, so Vinay, in your case, what was the issue? Was anyone able to do it? Not getting output. You're getting an incorrect output or what? Satya. Okay, okay. Today's questions in this week's assignments are hard. Okay, so let's start. Now let's say we had to do it with loops. So how would we do it? We have words and we have three functions. Okay, so let's do it without using filter first. So maybe we can translate that code into the filter code. So we are given words. So let's say we have output as a blank list. So for word in words, for letter in word, if letter in vowels, what are vowels? In fact, we can keep this global. A, E, I, O, tuple. So if letter is in vowels, so what will we do? Let's say mask dot append true. So if we are maintaining a mask, when we see a letter, if we say that okay, it is a vowel, we append true, otherwise we append false. Mask dot append false. So now that we have done this, if all mask, that is everyone in mask is true, output dot append word, and we return output. So let's see if this works. Yeah, what? Let's see. Let's see. Debug in this code. Solution 3. So we have UAE. Notice that AI was missed, but UAE was pronounced to be correct. This is also all vowel. This is also all vowel. Now the thing is, the comparison is case sensitive. So when we when we are comparing, it is better to do word dot lower. So this changes word into lowercase. Notice that it does not affect the actual word. If we run it now, AI and UAE are both there. It's just that when we iterate over the letters, we are iterating over small case letters. So the comparison with vowels is easy. So this is how we would do it if we were allowed to use loops. Now let's do the same thing using filters. We have only vowels and we take in words. So we say output is equal to say, let's first create a filter is equal to, by the way, we can't use filter like this because it is a function in itself. So maybe just put an underscore or something. So we want to filter a list. Now the way filter works is the first part should be a condition that is based on which you will check whether to keep it or not. And the second part is the iterable. So the second part we know is words. Now, what do we want to do with every word? Okay, so let's say we have lambda x, or maybe just word. What do we do with word? We notice that this part will take one element at a time from the iterable. So we can name it x, we can name it word. So let's name it word. So letter in word, letter for letter in word, yeah, letter for letter in word. So this is basically just iterating over each character of the word. Okay, from words we take one word. For every word we create a list. Now what do we do with the list? We say true if letter in vowels, else false. True if letter is in vowels, else false for every letter in the word. Okay, so this is a list, and now we can apply all to this. That is, check this list. So you'll notice that all returns just one value, either true or false. So we have a condition and we have an iterable. So this gives us a filter. Now we have to generate a list out of the filter. If you remember, filter is not a list. You can convert it into a list using this function. So if we return output
Underscore.
and yeah, thank you. So if we return output, it works. We just forgot the load. Yeah. So notice that these many lines of code is equal to just one line of code. In fact, if we just write list here and we remove this and we straight away return this, all of this is condensed into one line. Does anyone have any confusions? Is it clear? By the way, we can condense it even further. So let's say we have our vowels. Let's say our word is hello. So if I do letter for letter in word, so this is HELLO, okay? Yeah. So if we do, we say write true if letter in vowels, else false. For letter in this, a short form for doing this is just writing letter in vowels. Okay, letter in vowels. You can do it like this. Let's say I write I in vowels. It's just a true or false value. Okay, so we are just writing the same thing in a condensed fashion, that all of this true if letter in vowels, else false. It is the same thing as writing letter in vowels. For every letter, check if it is in vowels or not. Okay. So if we condense this, letter in vowels, still works. So can you do the other two now using this? Maybe take 5 minutes. Uh, Guram, I apologize if I am not pronouncing your name correctly. Is this clear? Is this function clear? The one in comments. No, I'm asking this. Yeah, so this line essentially does the same thing as this. So what are we doing? We have an iterable that is words. In filter, there are two arguments. The first one is a condition, that is it should return true or false on every element of the iterable. Okay. So when we supply filter, it will take every element of the iterable and test whether the function supply returns true or false. So what is our function in this case? Our function is a lambda function, as we explained earlier. It takes one word at a time. So what do we do with that word? We create a list of letters from the word, that is simply letter in words, and we apply lower for the case sensitivity. Then we say, is the letter in vowels or not? Okay, as we did here for letter in lower. If the letter is in vowels, mass dot append true, else mass dot append false. The same thing is this part. So as we wrote earlier, you can expand it like this. True if letter in vowels, else false. Notice that this is exactly the same as this. Mass dot append true, mass dot append false. So you are doing the same thing using list comprehension. And we are condensing this part further by writing it like this. Once you have a list of basically Boolean values, true or false, you check whether everyone is true or not, because the function is only vowels. So if everyone was true, all will return true. If all returns true, then that word gets a clearance basically from this function, and filter will accept it. If it was false, filter will reject it. Is that clear, Guram? Yeah, so can you try the other two using the same? I mean, it is very easy now. Just use this part again for any vowel and no vowels. Yeah, how many of you were able to do it? Should be pretty easy. No one was able to do it. The other two functions. You just have to change this line slightly for these two functions. Okay, so does anyone have a confusion in this line? Because if you were clear on this line, you should be able to do this and this. Are you still confused in this line?
So can you show the question, sir, once? Or
Yeah,
the output?
Yeah, so as I was saying, is everyone clear on that line? This line.
How we use filter function.
In filter, the first, as I said, the first argument is a condition. The second argument is an iterable. The condition is applied on every element of the iterable. And if the condition passes, it is kept in the list. If it fails, it is dropped from the list. Like this. It's basically a condensed version of this. No, Krishna, no. So what we are doing is when we are creating a new list which only has true or false values. We are not changing the word basically. Lambda takes an input as word and it returns this thing as the output. The word itself is never changed. It's never altered. For each iteration, initially the word would have the word, basically, yeah, the element from the list. After evaluating all, either true or false is returned to this. No. The true or false is not returned inside the variable word. It is returned as a separate value. So basically, it's maintaining a list like this, a mask like this, and this is the return. The mask is returned to all. All then works on that mask and returns true or false. Word itself is not tampered. So, Bhavani, were you able to do it?
Yes, sir.
Okay. So let's do the other ones. I've basically expanded this one line into these 4 lines, maybe for readability, that you are supposed to create a list out of a filter. The filter takes two variables, the first of which is a condition, a function, and the second one is an iterable. You can write it in one line, you can expand it in multiple lines. So for any vowel, we will basically do again list filter lambda word. Instead of all, there will be any. And for no vowels, we will just put letter not vowels. And if we try again, any, no. So the last one is wrong. Oh, sorry. Yeah, works. So there is one more improvement that we can do in this thing. And by the way, how many of you are not aware of the GitHub that we are maintaining for this course? Is everyone aware of the GitHub page, the GitHub repository? On God, you were there with me last class. Yeah, so we are maintaining, if you go to the YouTube channel, let me show you. Is the screen visible?
Yes, sir.
Yeah, so if you go to the channel, we are maintaining a playlist of the live sessions. Here you will see find code at. So everything that we cover in our sessions, we post the code at this repository. So let's say week 2, you have the problems and the corresponding solutions here in case you want to refer to it again. So I will post these there as well. So let me give you the URL. No, you don't have to use GitHub. It's a different thing. You can just view it here, like go to week 2 solutions, match braces, and you can just copy the file, copy raw file, and then you can create a new file and just paste the code here for reusing or for altering it. You don't need to know how to use GitHub. So I was saying there are a few improvements that we can do to our code. In this case, I have written them in tips. So there is something known as a generator, and the other one is list. Okay, so let's say we have list range. Maybe we can write it something like this. List range 10. Okay, so we get numbers from 0 to 9. If I only write range 10, this thing is a generator. This thing is a list. Now, what is a generator? Okay, when we loop, let's say for I in range, if I supply a big number, let's say 100,000, it never materializes the list of 100,000 elements. Okay, what a generator does is it knows I am supposed to supply one value at a time. So let's say I want it to generate a list going from 0 to 1 million. It will not store the list 0 to 1 million in memory because that is useless. What it will do is it will maintain the count. Okay, I am at 0, supply 0. Okay, 0 is done. Next time supply 1, supply 2, supply 3. So it is sort of a function which supplies one value at a time, but the entire thing is never materialized. Okay, so in this case, if you see here, letter in vowels for this thing, if we in fact try it here, EO, we have vowels, AEIOU. Word is, let's keep it small. So word, so we have L for L in word. So this is a list. If I use circle braces, it will return a generator. Okay, a generator. If we store this generator, let's say in gen, I can iterate over it. For I in gen, print I, Notice that it gives me hello, but it never stores this list HELLO. So in the same way, if we just replace these square brackets with circle brackets, we have improved our code from a space complexity perspective. We are doing the same thing, but we are never storing the letters of the word itself. Okay, that is this true false thing. We are maintaining a generator and we supply one value at a time. So is that clear? I would implore you to maybe read more about generators. For example, the range is a generator. So when should you use a list? When should you use a generator? In fact, in this case, maybe the generator doesn't make much of a sense. Letter in vowels. Yeah, in this case, I think it may actually do the same thing because it doesn't know how many it's supposed to get. So true, false, true, false. So it will still have to store them all at a time. But in case a generator knows that, okay, the next value is going to be this, it is better to use a generator instead of a list. Okay. So for example, I said in this case, let's say we had range 10 or maybe a huge number. It is better to use a generator if you don't want to store the entire thing in memory. And it is better to use a list if you want to access the elements. I mean, maybe you want to use it again and again, or you may want to index some part of it. You cannot index a generator, if I remember correctly.
Sir, I have
So
a question here.
would you use a generator on the for loop above, like for loop that you used to explain only vowels? Then maybe it would be clear.
Yeah, in this part.
Yes. So for letter
Yeah,
and
in this
word
case.
lower, I know this will take out a list. It'll just iterate through the entire thing. Can a generator be used here as well?
Yeah, I believe it would use a generator because it won't expand it into a list at a time. I think it would in fact index it one at a time. It knows that word is an iterable. First time give me word 0, second time give me word 1, third time give me word 2, rather than expanding the whole thing.
Okay.
Sir,
So could we not use a generator in the mask because we're not trying to save the mask, right? Although there's a list mask, but we're not using. How would we use a generator for mask, for example? Is my question.
So basically, if all is supplied a generator, it will iterate over every value, true, 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 false, true, one at a time. And it will see, have I seen only trues or have I seen a false as well?
So in the for loop, is it possible in the for loop above?
Yeah, in the for loop above, yeah.
Using generator only in the mask because mask is a new list now here, right? That's my question. So instead of using a list, if we can use it in a generator form, it's a thought. It's a
Yeah, but how would we create a generator in this case? That is the issue actually.
okay. Okay, so we can't use it over here in for loops easily.
Yeah, because we are going one element at a time and we are appending. So there may be a may, I'm not aware of it. I mean, I usually create a generator when I'm doing something like this. I'm not sure, like to be honest, if there is a way to create a generator in this case, but when I personally use generators, I use it in this case. That is if I have a huge iterable, yeah, I have a huge iterable and I don't want to store that in memory, I will go over it like that. I think someone else has had a question as well. I think Bhavni had a question.
Yes, sir. So, like if we see your code, sir, back code screen. Okay, so in this all, so you're using a generator here, right? So here, whenever we use all, then it means it will check all the values of that list if everything is true. So now here, if it is a generator, how will it check one by one? Because will it store that somewhere in memory? Because I'm not able to visualize how does it really work.
Yeah,
Because
let's say, yeah, maybe I believe, let's say I have 10 values and I have a generator. It will take in the all knows at the moment I see false, I'm false. Right.
Okay, okay. So it will just even it will not even run the code.
Yeah, in fact, that would be more efficient. That would be more efficient.
Got it, sir.
And the same case with any says I see one true, that's it.
Okay.
right?
Yes.
So in fact, a generator may be efficient in this case. I thought it may not be efficient, but on second thought, it will be efficient because it may not see the rest of the values, but when we are storing a list, we are unnecessarily storing everything, maybe, right?
Right, sir.
Yeah. By the way, if you're not comfortable with this, any of you, it's, I mean, perfectly okay to do it like this. In fact, I would advise that if this thing becomes very complex, like some people are very like fancy about this, they will use filters and maps everywhere. But if you feel that this is becoming too complex for a reader, it is better to expand it like this. I mean, it is okay in this case that maybe basically an experienced Pythonista can make sense of this. But if the code is even more complex, it is better to avoid nesting like this and maybe expand it like this for, I mean, in favor of readability, basically. So it's not always advisable to merge all the lines into a single line of code. I mean, people, you should know when to use list comprehensions and when not to use list comprehensions for the sake of readability. So I think we're out of time. I will post this code at GitHub. By the way, can you all access that? GitHub?
Yes, sir.
Can you confirm? Yeah, so I'll upload week 3 there, and I'll upload this video in case anyone wants to watch it again. Please explain merge sort and quick sort. This session is actually for problem solving, so you will have to connect with your basically teacher, the lecturer, for that. And yes, you may rewatch it, find some videos on YouTube or something. This session is primarily for problem solving. So does anyone have any questions for the three problems that we discussed? So the new things were filter, list comprehension. Oh, I forgot one thing. An important thing. There is another thing in tips. Notice that when we do list comprehension in your lectures, I saw this. That is, let's say we have word and it is hello, and we have vowels. That is A, E, I, O, and U. So let us say I do this. True. In fact, in your lectures, you will see something like this. Letter for letter in word, if letter in vowels. Okay. So notice that it gives me a sublist. If I write it like this, I cannot use an else statement. This is very important and often confusing. I myself make mistakes sometimes. I mean, let's say I want to store true here. True for letter in words, if letter in vowels. Okay. So this gives me true, no false. Now, in case I want to say false as well. So let's say I have if letter in vowels, else false. This will not work. Okay. So this is a very limited syntax in this case. That is a for statement followed by an if statement. This is usually used for creating a sublist. There is no else part here. If you want to use an else part, you have to use it inside the for loop. That is, rather than writing it this part. If letter in vowels else false, you have to write it before for it to work. Otherwise, it will throw an invalid syntax. So we will write true if letter in vowels, else false if letter in vowels. And wait, true if letter in vowels is false. Sorry, uh, for letter in vowels. So notice that we get true if letter in for true. Why is everyone true? Oh, sorry, for letter in word. So we have false, true, false, true. Notice that in the case above, I mean, we'll mess this up actually. Let's write it in a cleaner fashion. We have word is equal to hello. Vowels is this thing. So if we write letter for letter in word, if letter in vowels, it returns E and O. In case of I want to do this, true for this and this, I will get true, true. Now, if I want to store false as well, I cannot write else at the end, else false, it will throw an error. If I want to store that, I write it like this. True if L in vowels, else false for L in word. And now I get false, true, false, false, true. Notice that this has, I mean, we were supposed to get 1, 2, 3, 4, 5 elements, but we are only getting true. So this type of code where if is at the end is used to extract a sublist. And this thing where you write if and else before the for loop, it is used to generate a mask. Okay, so these are two ways to do it. I think there is a third as well, which I wrote. No, these are the two things. So if you want to generate a small list, that is, you only want to check membership and keep the ones that satisfy and discard the ones that fail. You keep if at the end and there is no else part because you don't want to have any else part. There is nothing else you want to store. Now, in case there is a decision to be made, that is, if this is true, write this, else write this. You need to include if and else before the for loop. In fact, I would advise that you always use this one, maybe. But I think if you don't supply an else part, this will throw an error. True if this, yeah. Now this expects an else part. So if you only want to check for membership and reduce the size of your list, you put if at the end of the list comprehension. If you want to make a decision, that is, if this is true, store this value, else store this value, you write if and else before the for loop. Okay. If you do anything other than that, it will throw an error. So I think this will be useful for you.
Sir, I think like in the lecture, sir was explaining that map should come before for and condition should come after for. So whenever we're using if else, it means it's mapping. We are mapping all the values to something else. So that is why it should come before for. And
Yeah,
whenever
yeah,
we are using
exactly.
only if, it is like a condition. So that is why you have to use after for.
Yeah, yeah, yeah. Nice. By the way, if you want to access the YouTube channel, I mean, you can just search NPTEL and my name, ARMAGAN. It should throw up this channel. You can maybe confirm. I will also share the link. Can you access the YouTube link? In the last session, there was a student who wasn't able to access the link. So can you confirm?
Yes, sir.
Yeah, okay. Okay, so we'll stop here. See you all in the next session. Bye. Bye, everyone.
Thank you, sir.